Hello and welcome to the first session on the PCB design. You may be wondering what is this PCB and why we are studying it. PCB stands for printed circuit board. It is widely used in electronics, and without PCB, it is quite difficult to work with electronics. So PCB has lot of electronics component interconnected to each other. So let's try to understand what exactly is PCB. Okay. As you can see, there are some images of the PCB shown here. So for example, if I open this, as you can see, there are a lot of images of PCB I have Googled. So let's open one of them. So if you can see, this is a PCB and there are different component of these different size and shape, um, which are fixed onto this board, and there is some tracks and pads going from one point to other. So this is how a PCB looks like, and this PCB has the circuit and the component onto a single board. That's why it is called as printed circuit board. But there are different types of PCB. So one is single-sided PCB, other one is double-sided PCB, and there are multi-layer PCB. Also, we can see some flexible PCB and all of this. So these are different types of PCB. I can show you some of them. Just a second. So just Google single-sided PCB. So this is a good example of single-sided PCB. So as you can see, we have this board, and we have something which is called as a substrate, and then on the top we have the copper layer, and on the top we have these solder marks. Single layer PCB is where we have the copper layer on only one side, and we have the substrate. But in double layer PCB, we have the copper layer on both top and bottom part of the PCB. But in multi-layer PCB, we have the copper core on both top and the bottom, but also we have the copper on the middle layers of the PCB. So there are different layers according to the complexity of the PCB. So it may be 4 layer, 16 layer, and so on. So they are interconnected to each other with the help of via and dia. So this is a via, No problem if you are not able to understand it right now. We will cover all of this topic one by one in the next upcoming sessions. So just try to understand some of the concept. So this is a wire and it goes from top to bottom layer, but this brown part which is copper is also going in the middle section. So it is interconnecting somewhere. So it interconnect in the middle layers. So this is a multi-layer PCB where we have the copper on the middle layers of the PCB. But we will have the component on the top layer and on the bottom layer only. So these are the different types of PCBs. Okay. So these were some of the concept related to the PCBs. But there are different types of component based on their surface layer. So the first one is the through hole component. So this classification is based on how we place the component on the PCB. So first one is the through hole component and the second one is the assembly component. Okay. So a through hole component is where the leads. So this is a resistor and it has two leads. One is coming out and going into this PCB board, and the other end is coming out and it is soldered here. So it is through to the board, as you can see this through hole. So the component lead will be passed from one layer or the top layer to the bottom layer. So this is an example of a through hole component, but I can show you some more example. Yeah, this is a better example on a through hole component. So the lead is soldered on the top as well as the bottom part of the board. So this is a component and we have this PCB. This lead of the component is passed from this uh, PCB as a through on the both side. So and we solder them on this pad. So this is an example of a through hole component. Next is the assembly component. So this is a capacitor, and if you can see we have this PCB board and this is the pad. We have this component as a capacitor which has two uh, areas where we can solder the component, and it's soldered with the pad. So it is only on the surface of this board. We solder it only on this surface of the board. We can solder it on the top or bottom layer according to our circuit or the PCB designed. So through assembly component are soldered only on one side of the board, any one side of the board. So this is a connector which has the lead in the form of SMD. So we solder it only on this surface. It is not through and it does not go from one layer to another. So this is an example of an SMD component. So these were some of the basic concept related to the PCB and the different component. Hello and welcome to this course. So in this session, we will start with our first project. In order to create a first project, you need to open your EasyEDA online editor, and then you need to go to this file, then click on this new, click on this project. Give the title of the project. I will give it as a PCB board at Mega 328 and write some description related to this project. Arduino clone at Mega 328. Okay, and then click on the save. You have created your first project. As you can see on the left side, you have a drop down which is represented as a sheet underscore one. So this is your sheet where you will draw your schematic, and there is some outline of this schematic. You can change the size of the schematic. Just click on this, left click on this, and on the right side, the sheet's properties appears. So it represents the paper size. So the size of your sheet is in A4. You can change it to A3 or A2 or A1 according to your schematic. Then next is the orientation. Either you make it landscape or portrait. Then the size, you can customize the size of this sheet. This is the color. Then we have the location of the sheet which is starting from, and the Y location. So you can also lock this sheet so that it will not change. Then we have some palettes, which is the wiring tool. The first option is the wire, second is the bus, then we have the bus entry, then net label, net flag ground, net flag ground. Then we have the net port, VCC 5 volt, no connection. So this is a easy drag and drop tool which you can use it. Also we have this drawing palette. Now you can zoom in and zoom out from your mouse. Bottom you can see this title of this project. So if you write this at PCB board at Mega 328, so you can change the title of the project, revision of the project. Just double click on this, double left click, and you can easily change the date and all of this. Hi, in this session we will see how we can design a schematic. For that we will need some component, and then we will connect those component to each other. First I need a microcontroller. For that we need to add the component. So at the left there is two options. One, we can go to this library and search for the component, or we can use this common library. The third option is the LCSC parts. So I prefer to use the LCSC parts. Just click on it and it will open a new window in your web browser and search for the component which you need. I need Atmega 328P microcontroller. I will search for the component here. So it shows some result. I will use SMD component. So you can see the images of the component, the pricing for the component, quantity. This is the store from where you can buy this component, but we need the footprint and this symbol so that we can use it in our schematic. For that, you need to scroll at the right side. Just copy paste this LCSC part of the component which you need. Just copy paste the LCSC part of the component which you need and go to your EasyEDA. Then click on this library and paste the part number here. As you can see, we have the footprint, symbol, and the 3D model of the component. At the bottom, just click on this place. This will be tied to your cursor. Just left click and you can see the same component is tied to your cursor. Now you need only one component to be added here. So you need to click on escape to release that component. Place it in the center. I need some capacitor. So there are different package available for this component in the terms of the resistors and the capacitor. So for example, if you click on this arrow key, you can see 06, 03, 02, 01. These are the sizes of the individual component. I can select 0402 and so you need to click on this component and it will be tied to your cursor. In case you need to rotate this component, click R from your keyboard and place it wherever you want and place them where you need to connect it. In case you need to copy this component, left click, Control C and then Control V. So this will copy and paste the component. I need one ARF 1.1 microfarad to be placed near the A reference and it should be pulled to ground. I need one resistor and one reset button. So you can search for that component in this library. So we will pull the reset button to 5 volt. need one reset button. You can get the 5 volt from this wiring tool palette. Also, you can get this ground. In order to microcontroller to work, we need the crystal oscillator circuit. In order to move the component, just click on it and just drag it wherever you want to place them. I need 16 megahertz crystal. To complete this crystal circuitry, I need capacitors of 22 picofarad value. You can change the value of the component by double left click from your mouse and add the value of the component which you need. For example, 22 picofarad. Just click enter. I also need the ICSP header. This is connector header. M2 cross 3. Now let's start wiring them. Remember, in the microcontroller circuit, we need to give the 5 volt to the VCC and we need to connect the ground to the ground. In the wiring tool, the first option is the wire. Just left click on it and start connecting the start and end point of the each component. For example, I need to connect this capacitor. So you move your cursor at the start point and left click from the mouse, and you can see the wire attached to your, which is hovering with your mouse. To make a good connection, just click on the point where you need to connect it. It's that simple. I will connect this reset. Now I will label this or connect this ICSP header with the HPI lines. So the first one is the MISO. So in order to make a connection, I can use the net label. To change the name of this net label, left click from the mouse and you can write this. I will copy and paste it. Connect the serial clock at the serial clock pin of the microcontroller, and we need to connect this reset. In the last session, we have designed the schematic for the microcontroller circuit. So let's draw the click on this rectangle from this drawing palette and create a outline for the schematic. Left click at the start and you will see these rectangle or the box coming out from there, and you end it by left clicking from your mouse. So this is our microcontroller circuit section. Click escape. In the drawing palette, you will see the T as text. Left click on it and left click above the box. Double left click to change the name. I will write it as microcontroller circuit. So it's, it gets a better understanding of the circuits used in a schematic. I can, if you want to move this schematic, select all of them and drag to the top. Next part is the schematic design of the USB circuitry. Let's start placing the component for the USB circuit. First, I need the IC, which is used to program the microcontroller. I will use the CS340G IC. Go to the LCSC parts and search for CS340G. This is the IC which we will use. It is an SMD IC. You need to copy and paste the LCSC parts. Go to your EasyEDA and click on library. Then paste the LCSC part here. Click on search. You will see this footprint and the symbol of the CS340 IC. Click on place. Now the CS340 IC will be tied to your cursor. Left click wherever you need to place the IC. Click escape. Now start adding the component associated with this CS340 IC. I need 0.1 microfarad capacitor. I can copy and paste this from a older schematic of the microcontroller section. Reset pin of microcontroller needs to be connected here. So I will copy paste the reset net label. I will connect the TTR pin with 1 microfarad capacitor. If you do not connect this 1 microfarad capacitor, this ESTP40 IC will not work. The CST40 IC also need the crystal circuitry. I will search for the crystal circuitry in the LCSC part. I need a crystal, which is 12 megahertz. I need this 12 megahertz crystal. And I need 18 picofarad capacitor. Connect all of the components. The CH340 IC communicate with the microcontroller circuit using the UART communication. So the TX pin of CH340 IC will be connected to the RX pin of the microcontroller. In between, we need 1 kilo ohm resistor. I will use a net label because I cannot drag a wire from here to there. It does not look good. So from the wiring tool, click on this net port. So the TX will be connected to the USB RX and the RX will be connected to the USB TX. Copy and paste this net label at the RX and the TX pin. Make sure you connect the RX with the TX and the TX with the RX. So the RX of USB RX is connected to the TX of CS340 IC. This completes our CS340 circuit. But in order to program and connect the microcontroller and the CS340 IC with our system, we need a USB connector. We will use a mini USB connector. Go to the library and search for mini USB or search for the part number from the LCSC electronics. So we will connect this USB with our system. In order to protect our circuit, we need a diode. So that the reverse current from our circuits will not go into our system. Also, this we will receive the 5 volt from this USB. So we will need some capacitor to block the high and low frequency components. In order to receive the data from our system to the CH340 IC, we need to connect the data plus and data minus to the CH340 IC. For that, we will use the net label and change the name of the net label. So the data minus connected to data minus, data plus, data plus. So this net will be connected to the CH340 IC. As you notice, there are some pins on the ICs which are not connected. So in the schematic design, we will need to use some flag to indicate that these pins are not connected. So from the wiring tools, click on this no connect flag. You will see a green cross tied to your cursor. Go to the pin where the pins are not connected and left click at that pin. So it indicates that these pins are not connected. This part completes our schematic. We can name them. This is the CH40G IC circuit and this is the USB circuitry. So now this completes our schematic. After completing the schematic, we need to uh, uh, check the electrical connection. In the next session, we will see how we can convert the schematic into the PCB. Thank you. Hello and welcome again. In this section, we will see how we can convert this schematic into the PCB. Before that, I would like to add one circuit. So we are getting the 5 volt from this USB, but we will use an LED to indicate that we are getting a 5 volt. It looks good. So we will use one 1 kilo ohm resistor and connect an LED. So LED is 0603 red, green, blue. I will select green and click on Ctrl S. the EVA schematic. Now once we have completed our schematic, we will need to place and route all of the component. From the top toolbar, click on design and then click on convert schematic to PCB. So a new window opens in which it represents the new PCB, and this is the board outline properties. Your board outline will be in millimeters or mil, and you need to select the number of layers. So our PCB will be a two-sided PCB. Start of the board should be 0. So this is the board, and if you see it is in a different color. There is a palette which is layers and object. So in this you will see different layers represented by different colors. As we click on it, all of the colors are changing, which represent the different colors. And in the this is the copper top layer, bottom layer, and middle layer. This is the all of the non-copper layers. Now this is our board, and these are all of the components of our schematic. Let's start placing all of them one by one. I prefer placing all of the component as per the schematic. For example, this is our USB circuitry. We select all of the component. As soon as you go in this PCB board, you will notice the selected component has been highlighted in white color. So you just need to left click from your mouse to move it anywhere you want. So these are the four components which you have selected here. So it is easier to for us to place them according to our circuit. Let's start placing them. Left click from on the mouse and drag it. In order to rotate it, click R from your keyboard and place exactly at the corners of the board this way. You need to place the connector exactly at the corners so that you can easily connect it. Now, if you see as I move this component, there is this connection which is moving, or the line which is called as ratness, which moves as the component moves. So you need to place them according to this line. So this line should have a minimum distance between each other. So I have placed this capacitor C11 very close to this capacitor C12 so that it makes a connection. Also I can rotate this diode. I can place it here. Similarly, do it for all of this circuit. Select them, drag it. So you can identify that this is a USB CH340 circuitry. First, place the IC. I can move them a little bit up. Place it. Okay. So in this circuitry, we have the crystal circuitry. So you need to place the crystal circuitry as close to the pins as possible. But for that, you need to first identify the crystal. So you just click on this crystal and search for the crystal, which will be highlighted in white. Drag and drop it very close to the pins. See, crystal circuitry also has this capacitor. You need to place this crystal capacitor according to this connection. The ground is facing outward. Similarly, ground is facing outward. Now we are left with 5 component for the USB. There are two resistors. I can place one here, second one here. Place the decoupling capacitor as close to the pins as possible. Next part is the microcontroller circuit. Place the ICSP headers. Here. Same thing for the microcontroller circuit. You need to place the crystal circuitry as close to the pins as possible. First, I need to change the its value of the component. It is 1 mega ohms. So if you change any value in the component, so and you need to update that, so go to design and then click on update PCB. But before that, you need to scale the schematic, then click on update PCB. So the changes will be applied here. Then select this 1 mega ohm resistor. So as you can see, I'm placing them 1 mega ohm as close to the pins as possible. And then we have this crystal. You can rotate this seal screen naming of each component. Then I need these two capacitors for the crystal circuitry. This is how you need to place the crystal circuitry for this microcontroller. So I will place this R1 resistor close to this reset pin and the pin from the microcontroller so that it makes a connection easy. Go to the schematic. So this two decoupling capacitors will be placed to the close to the microcontroller pins as possible. So we have this 5 volt, this ground, which will be connected here. Then finally, I have left with this uh, power indicator LED and its resistor. So I can place it here. This is how it will look once we complete the placement of component. Once we have placed the component, it's time to route the tracks. From the PCB tools palette, click on this track. Now click on the first pad. You will see the tracks which is in red color is tied to your cursor. As you move the cursor, the tracks is also moving, but it is showing the point at which we need to end the track. So this is just the next pad where you need to end the track. So this white line navigates the helps to route the tracks. And also if you notice there is a 45-degree turn to route the tracks. Just left click at the very next pad. So this is a connection between the two pads. Now there is also connection between this pad and this pad. After that the blue line disappears once we do the connection. You can also change the thickness of track according to the flow of current. So we need to calculate the amount of current which will flow from this track, and then we need to increase the thickness of the track. So just select this and come to the track properties. First thing, how we came to know that this track is in top layer. Because of this red color, we can change the layer from this layer section. As soon as I change it, you will see that this track has been in blue color, which represent the track is in bottom layer. Let's make it in top layer. We can change the thickness of the track from this. It's in mm, zero point 0.5 mm. I have changed it to 0.5 mm. So this is how you can change the properties of the tracks. There is an alternate way to route the tracks. First I will delete this. So this is a small circuit. We can route the track manually, but there are some complicated circuit which you will design. So EasyEDA has a very good feature of routing the tracks. For that thing, EasyEDA has the auto router. So from the top toolbar, go to route and then click on auto router. So once you click on this run, this will auto route all of the connection inside this PCB. But before that, I will add some mounting holes. So you can get the mounting holes from this PCB tools palette from this hole. Just left click and left click where you want to place the mounting holes. But the important thing is we will fix this PCB with the help of this mounting holes. So the distance between the four mounting holes or the mounting holes should be same so that we can get a good mechanical strength. So place it and then you will see the diameter of the hole, which is 2.03 mm. You can change it. You can change it to 3.2 mm if you want to use a 3 mm bolt so that it goes through and we have a 0.2 mm distance so that the bolt can easily go into this PCB. And then we have this direction or the exact coordinate. When we have the exact coordinate of these mounting holes, then we can copy paste at all of the four corners. But make sure you have the correct dimension, correct position of this mounting holes. So now I have placed all of the four mounting holes. You can view this in 3D viewer or 2D viewer from the view and 3D view of this PCB. So this is how it looks like. These are all of the 3D model of individual components, and it will look like this once your board is manufactured. You can change the color. Let's go to the board and route the tracks. For that, go to the design. For that, go to this route and then click on auto router and then click on run. So it will start the auto router. After that, once the routing is completed, you will see this information on the screen. So it is saying that attempted 79 and completed 79 100%. Failed 0. There were total 11 VRs, and then we need to click on OK. So this is how the auto router works. We need to add the copper port to this board. So for that, you need to go to the PCB tools and then select this copper area. After that, a window opens up which shows the net as the. Then we need to select the ground net. So we need a ground copper port and then click on this. Okay. You need to um, start it at all of the corners of this board. At the end, we need to right click. So this is the copper port on the front layer or the top layer, but you see the corners are not done properly, so you can just drag it all of the corners, so it covers all of the corners. Now from the right side, you click on this rebuild copper area. Same thing we need to do on the bottom layer. So this is how it will look like at once you are done with the PCB. You can measure the dimension of the board by using this measure tool. So this is our board dimension. We can also have a 3D view of this, and then see the board. So at the end, this is how our board will look like.